Scotty Powell, I'm very confused about this whole fascination about the blue water in Myrtle Beach. Isn't water supposed to be blue?
It is supposed to be blue, and a lot of times it is blue, but sometimes when you get to Myrtle Beach, you kind of see that grungy looking water, but there is something special going on here.
It's not grungy. Is that what you're saying?
It's not grungy right now. So just give it a couple of weeks or whatever. But it does have that tint of like you're walking in the Keys or the Caribbean islands. Like you can actually see the bottom, not just where your feet are, but a couple of feet out, I guess it's the big deal. But the reason why I learned about this is basically we've had a fairly quiet storm season so far. So to get those kind of murky waters, you have to have upwelling, but we've not really had any storms out in the ocean. So all of the sediment and phytoplankton, listen, I've learned about this all day today. This was my breakout today for our show. The phytoplankton, it all retreats out to the Gulf stream where the warmer waters are, where there's a little bit more upwelling with storms. So that has allowed.
Nope, there's that.
No, not again.
Did I go out?
Yeah, could you say the last part again?
So what happens is there's no storms out in the ocean right now. Tropical systems are just thunderstorms, a lot of thunderstorms. So the phytoplankton recedes to the Gulf Stream where there has been some convection and some rougher seas out there because of thunderstorms developing. So the phytoplankton's out there, and the ocean close to the shore here in Myrtle Beach, the sediment, we get runoff from rivers and streams and stuff in North Carolina that kind of flows into the ocean. That has kind of settled to the ground or the ocean floor. So there's not a lot of wind. There's not a lot of strong onshore flows. So it's allowed the waters to be pretty crystal clear blue. And it's something that it's so funny, but my chief meteorologist, Frank Johnson, and I were talking about it today. We're like, we always thought it was this way, but people have been making a big deal about it being really clear. So we dug into the research and figured out why.
All I hear you saying is come to Myrtle Beach where the water's less icky than usual.
I mean, the Chamber of Commerce should be doing some commercials or something right now, because it is a huge talking point in all of Myrtle Beach. I mean, if you scroll on the Facebook, the Twitter, you just see people commenting on how clear the water is. So if you want some clear water, come on down to the Grand Strand.
One other thing that could be brought up about this, because the storm season's been quieter than usual, there's not as much churning and upwelling going on. And so the waters are warmer than average. Yes. It's actually really warm. Yeah. There's an 89 reported at near McClellanville right offshore.
To piggyback off that, Frank, it's funny that you say that. Obviously it was a cool start to summer, meteorological summer, June 1st. As of like the 2.5 weeks into June, the ocean temperature at Spring Bay Pier was anywhere between 73 to 74. You may get an occasional bump up to 75, but it would swing back down. Well, now we are hovering 84 to 86 every day. So we had almost a 10-degree jump in the last 3 or 4 weeks, and is now consistently staying in the mid 80s. And like you said, Frank, a little bit further south, it's even warmer than that. I was looking at Winna Bay, and let me pull up the water temperature right quick. I believe it was also pretty high, 87 at Winna Bay North Inlet, Apache Pier, 85 degrees. And even going into North Carolina, near Carolina Beach, you're looking at temperatures 83 to 85. So the entire north, or at least the southeast coast of North Carolina into South Carolina, the ocean temperatures are pretty warm.
Yep, sure are. Down Charleston, some of these are in the upper 80s down there, 88, 89 degrees. Charleston Harbor tide gauge, that's in the harbor. It's 85 there. That's above average. It's stark contrast, like you said, to the beginning of summer, at the beginning of June, because we had that storm that caused the strong offshore wind. So there was a lot of upwelling, and the waters were really cool for weeks after that, but they warmed up and now they're above average.
Which brings us to a whole new point. You have warming sea surface temperatures, and we're getting into the heart of hurricane season.
Don't say it. Don't jinx us.
As you know, Frank,
shut up, Scotty.
We talked to Phil Klotzbach, and he said those two could offset themselves with this El Nino. So yeah, we'll see what the next 6 to 8 weeks holds in store for us.
If a storm comes our way and there's no shear to bail us out, we might have problems. Yeah, all these warm waters. Also, another thing to think about, if you're on the beach in the morning and there's thunderstorms in the area, warm water means water spouts. You got to watch out for them.
We had one in Cherry Grove on Saturday afternoon, very visible right off the coast. Several good photos of it. But yeah, the Weather Service in Wilmington, they put out their daily surf products and stuff, and they've mentioned water spouts for the next few mornings. So if you're visiting along the Grand Strand, you can maybe check one of those out. We just don't want it to move on shore. As long as it's out there in the ocean, we're
right. Okay. Yeah, let it stay a couple miles offshore.
And here now, the latest on the tropics. The outlook from the National Hurricane Center over the next 7 days has 3 areas of potential development, one at 20% in the Gulf of Mexico, 2 others out in the Atlantic Ocean, each with about a 50% chance of development. 2 circulation in the Atlantic, continuing to move off to the east. How far they get and how strong will yet to be determined. The next name on our 2023 Atlantic hurricane season name would be Emily if any of these storms were to reach tropical storm status. And as Scotty and Frank mentioned, certainly lots of heat, lots of energy out there as we head towards the peak of the hurricane season. Another heat wave these past few days here in the Carolinas. And you might be thinking to yourself, I know I am, it seems really hot this summer. And it is. It is abnormally hot this summer here in the Northern Hemisphere and across the globe. Earlier this week, NASA and NOAA both jointly announcing that July has set a new record for the warmest month globally on record. And yes, we set that same record back in June. So we now have a 2-month streak on a streak that we really don't want to see at all. And now let's take a bigger look at that climate change impact and that data analysis done and NOAA by replaying for you there from earlier this week.
Good morning. I'm NASA Press Secretary Jackie McGinnis, and joining us today are leaders from both NASA and the National Oceanic and Atmospheric Association, NOAA. We have NASA Administrator Bill Nelson, Kate Calvin, NASA's Chief Scientist and Senior Climate Advisor, Gavin Schmidt, Director of NASA's Goddard Institute for Space Studies, Carlos Del Castillo, Chief of the Ocean Ecology Laboratory at NASA's Goddard Space Flight Center, Sarah Kapnick, Chief Scientist at NOAA, and Russ Vose, the Chief of the Climate Analysis and Synthesis Branch at NOAA's National Centers for Environmental Information, who will be available for the Q&A portion. They'll provide an update on the latest temperature data from July 2023. And first, we'll hear from NASA Administrator Bill Nelson. Over to you, sir.
Hey, everybody. It certainly is self-evident that the Earth is heating up. And what we find is that July of this year, the temperatures are the hottest ever on record. If you compare it back to July of 2019, that was the hottest. And now this July has shattered the previous record from 2019 by 0.2 of a degree Celsius. So just look around you and you'll see what's happened. We have record flooding in Vermont. We have record heat in Phoenix and in Miami. We have major parts of the country that have been blanketed by wildfire smoke. And of course, what we're watching in real time, the disaster that has occurred in Hawaii with the wildfires, which were in part fueled by a typhoon or hurricane that was out in the Pacific. Well, we're trying to do something about this. And I'll take you back to when Senator Joe Biden and Sheldon Whitehouse and I were some of those senators who warned what was coming. And now, as president, Joe Biden, he's warning again, and he has a climate agenda, and that is very specific. And we can go over the details of that for you, but not only is it addressing the wildfires, the electric grid, the biggest climate change bill that has passed in the history of the Congress, all of that is happening. And I can tell you that NASA is all in. Most people think of us as a space agency or an aeronautical research agency. We are also a climate agency. And why? Because we have all those assets up there that are taking very precise measurements of what is happening. And from all of those measurements, we decided that we were going to, in the spirit of, if you remember on a space flight, you have a mission control center. And all of that information is in one room. Well, we have put together, along with other agencies, the Earth Information Center. First actual physical location is in the east lobby of our NASA building, downtown Washington. But we are making it available real-time information to everyone. And that's through nasa.gov. If you go to our website, you can locate it, you can tap on it, and you've got the information real-time on what these some 20 plus instruments that are up in space that are giving us very precise readings. What we have just put up, if you look in the recent past, we put up an instrument called SWAT. It is giving us the first time the elevation and the characterization of fresh water. First time. Elevation of water, lakes, ponds, rivers, streams, reservoirs. We put up tempo. It is giving us air pollution data. We put up emit to measure the mineral dust that is up drifting across the globe. And lo and behold, it gave us the definition and locations of methane emissions on the globe. And more recently, we put up a mission called Tropics that is helping us characterize further definition on hurricanes and typhoons. What we're trying to do is we're trying to bring space down to Earth. And I'll give you an example. About a year ago, I went to Kansas. I wanted to visit farmers there. I wanted to talk to them about the data that is available from our instruments in space that would give them specific information, for example, on the moisture content of their soil where they're planting their crops, so they can plan on their irrigation, depending on what that moisture content was. And that way, they can save a lot of water on irrigation. Or, for example, the information that we can give to prevent wildfires, we can detect disease in trees. And we can also give an indication from instruments for firefighters real time what's happening to that fire as we look at it from space. And another example, we are experimenting with a paint coating on asphalt in Los Angeles. And what we're finding is that it is allowing a neighborhood to be cooled by that paint surface reflecting the heat instead of it being absorbed by the asphalt. Well, the bottom line of all this is the last 9 years are the warmest on record. And folks, Mother Nature is sending us a message. And that message is we better act now before it's too late to save our climate. In other words, to save our planet. And the bottom line also is there's no political boundaries and there are no geographical boundaries. We are all in this together. Back over to you, Kate.
Thank you, sir. So we know from observations made on and above the Earth's surface that climate is changing. This July was the warmest July on record, and collectively the last 9 years have been the warmest since modern record keeping began. Climate change is having impacts on people and ecosystems all around the world. Along with changes in temperature, we're experiencing other changes in climate, like sea level rise, declines in Arctic sea ice, wildfires, heavy precipitation events, and more. At NASA, we're observing the Earth so we can understand both what's happening today, but also how that's changed over time. So we can observe the impacts of climate change, like sea level rise, wildfire, extreme heat. We can also observe the drivers of climate change, like greenhouse gases, carbon dioxide and methane, that are increasing in the atmosphere and trapping heat. By observing this, we can understand both what is happening now and also why it's happening and provide that information to inform decision makers and the public. So all of the data that NASA collects is publicly available, and we're working to make it easier to use so that people can understand what's happening in their communities and help plan for the future. And what you'll hear about today is a little bit more about the recent records and predictions of the future. And so I'll turn it to Dr. Gavin Schmidt to talk about recent data and observations.
Thank you very much, Kate. So we are producing today the GIST temp analysis of global temperature anomalies. These are an analysis based on weather station data, ocean buoys, ship records, and automatic weather stations in Antarctica and elsewhere, put together to give an estimate of the global mean temperatures, and that estimate goes back to the 19th century. The results that we're presenting today for July show that July 2023 was by far the warmest July in the record, more than 0.2 degrees Celsius warmer than the previous record, which was in July 2019, and more warm still than the last time that we gave a kind of mid-year press briefing on the temperatures, which was in July 2016. The temperatures in July are warming very, very clearly. What we're seeing here is anomalous, so it's above the trend that we would expect just from an extrapolation, and that's related to what's going on in the Pacific. So we have an incipient El Nino event that is happening, though we anticipate that the impacts of that El Nino event are going to build over time as we get towards a larger event towards the end of the year. And the biggest impact of El Nino will actually occur in 2024. So we're anticipating that not only is 2023 going to be exceptionally warm and possibly a record warm year, but we anticipate that 2024 will be warmer still. There are other things going on beyond El Nino. We're seeing extreme temperatures in the North Atlantic and in other parts of the ocean. These have been building for a while. You would have seen some discussion of that since March. There's a persistence to the sea surface temperature anomalies. that is helping fuel the warmth in July and through the rest of this summer. And one of the things that comes from that is because July and August are generally the warmest months of the year in the global mean, and that's because of the asymmetry between the northern hemisphere continents and the southern oceans. That means that this month is the warmest month in absolute terms in the record going back to the 19th century, though it isn't the warmest anomaly. So we've had bigger anomalies in February and March associated with the last big El Nino event in 2016. But what we're seeing here is the warmest absolute temperatures, and we know that that's having impacts. Kate mentioned it. We know that that is inducing heat waves. We know that it is leading to more intense rainfall. And we're seeing that very in many places in the world, and we know that it is a contributing factor to the growth of wildfires in areas that have been affected by the temperatures. Thank you.
Thanks a lot, Gavin. The oceans are experiencing about 90% of global warming. The last 10 years have been the warmest since the 1880s. And all these increases in temperature are not only felt at the surface of the ocean, but they can only be detected at thousands of meters depth. And there are consequences. As the oceans heat, the water expands. And when you combine that with the melting of ice over land, that contributes to increases in sea level rise, which are accelerating. And of course, the consequences are increases in coastal flooding, coastal erosion. And as an example, places like Miami Beach, they have been experiencing more frequent coastal flooding, only what we call, blue skies, about 5 times more than what they experienced 15 years ago. The marshes in Louisiana are disappearing also, in part also caused by the increase in sea level. Biology of the ocean also suffer consequences, right? These increases in temperature that we are seeing in Florida recently, with measurements approaching 100 degrees, exceeding 100 degrees in some areas, are bad for organisms. Not only are we seeing an increase in the frequency of coral bleaching, but we're also seeing coral, fish, and seagrasses die off. In other places like the East Coast, marine species of economic importance are migrating to colder waters. They're either moving north or going deeper. Unfortunately, coral reefs cannot grow legs and move away. So they have to stay put and experience the brunt of global warming. To add some insult to injury, all this CO2 that we are putting in the atmosphere also dissolves in the water and acidifies it. The ocean waters are about 20% more acidic than at the beginning of the industrial period. And this is not good for corals. And many other microscopic marine species that are at the bottom of the food web are also affected by ocean acidification. Now, coral reefs are not just these pretty things that are there for tourists to go and look at them. They are super important for the marine ecosystem. About 25% of marine species have something to do with corals. They contribute with medicine. They contribute with livelihood to millions of people. They protect the coastline from tidal surges and storms. So they are key to the health of our marine environment, and they need to be protected. Fortunately, NASA, NOAA, and friends and family in other national and international agencies have been collecting crucial data to understand how the Earth is evolving under climate change. And more crucially, we continue to work in the development of advanced measurements so we can understand our planet even better. Next year, for example, we are planning to launch the PACE mission, which will provide unprecedented measurements on the biology of the ocean, not only to understand how it works, but how it will react to global warming. And simultaneously, it will collect measurements of the atmosphere so we can look at how this atmospheric ocean system works. We're working on the Glimmer mission, which will provide very detailed measurements of our coastal environment, which are the ones that are feeling the brunt of global warming right now. And of course, NOAA is working on other missions like GeoXO, for example, which will provide continuity of measurements. So in the future, we can continue to study how our planet is evolving. And remember, these increases in extreme events not only affect the coast, they are also felt hundreds of miles inshore. So what happens in the ocean does not stay in the oceans. Okay? It affects the whole planet. So we continue to provide this crucial data so our decision makers, our policy makers can go ahead and do their job. Now I would like to leave you with Sarah, the chief scientist of NOAA, who will talk more about these issues.
Our data indicates that July 2023 was the warmest July on record for the globe, and it was the warmest July by a long shot, specifically by more than 1/3 of a degree Fahrenheit. That may not sound like a lot, but the margin for most global records is on the order of 1/100th of a degree or two. So last month was way, way warmer than anything we've ever seen. The warmest month of the year for global temperatures is also typically in July, just like it's usually the warmest month of the year for most places in the United States. Given that July 2023 was the warmest July on record and July is the globe's warmest month of the year, it's very likely that July 2023 was hotter than any month in any year since at least 1850. Having said that, the really important thing to remember is that July 2023 is just the latest in a long run of extremely warm months and years going back several decades. In other words, the long-term increase in global temperature marches on and on and on. We have now seen 47 consecutive Julys that are above the 20th century average and 533 consecutive months above the 20th century average. It's also worth thinking about El Nino and its impact on things going forward, as Gavin mentioned. El Nino tends to increase global temperatures, albeit with a several-month lag, meaning it probably did not have much of an impact on this July record. Given NOAA's forecast right now, there is over a 95% chance that El Nino will continue through the winter. We could see even bigger impacts in the winter and spring as El Nino peaks. While El Nino might not have had much impact on air temperatures, it did contribute to the record-breaking global ocean temperatures. For the 4th consecutive month, the global ocean surface temperatures hit a record high as El Nino conditions that emerged in June continued into July. Over 40% of the ocean is currently experiencing marine heat wave, with our predictions showing that that could continue into the fall or even expand. Meanwhile, in the far south, Antarctic sea ice coverage ranked the lowest on record for the 3rd consecutive month, contributing to the July 2023 setting a record for the lowest global July sea ice extent on record. Putting all this together, 2023 to date has been the 3rd warmest on record. According to NCEI's Global Annual Temperature Outlook and data through July, it is virtually certain, over 99% chance, that 2023 will rank among the 5 warmest years on record, with a nearly 50% probability that 2023 will rank warmest on record. El Niños can temporarily warm the globe by approximately 0.1 degrees Celsius, an equivalent to the expected warming over a 10-year time horizon. A year like this gives us a glimpse into how rising temperatures and heavier rains can impact our society and stress critical infrastructure over the next decade. It's important to remember that these years will be cool by comparison by the middle of the century if we continue to warm our planet as greenhouse gas emissions continue. Put another way, the next few years will be the coolest for the rest of my life if the world continues to emit greenhouse gases into the atmosphere. Thank you.
Thank you all very much. We will now take your questions. You can press *1 to enter the question queue. Our first question is from Jim Siegel with NASATech.net. Jim?
Thank you for taking my question, and thank you for doing this session. I'm planning to do an in-depth story about climate change, and I'm curious about where I can go to get the base data from which the conclusions are derived that you described today. Is that in the is that in the database that Bill mentioned earlier, or what? And I'm kind of curious too about how far back reliable temperature data exists in the United States. Thank you.
Gavin, do you want to take that one?
Sure. So the data that goes into the GIS temp product is all available at data.gis.nasa.gov/GIS-temp, and all of the data and uncertainties and analyses can be downloaded there. You can do the whole thing again if you want, but you can just get the answers if you want. The temperatures in the U.S. are actually pretty well sampled, even going back to the mid 19th century, and so the CONUS temperatures go back easily to the mid 1800s. For other parts of the globe, it's not quite so well sampled, particularly in the southern hemisphere pre-1920. But we have a reasonable estimate of global mean temperatures going back. We cut it off at 1880. Our colleagues at NOAA go back to 1850. And there's another product from Berkeley Earth that tries to go back even further. But the uncertainties increase as you go back in time.
Thank you very much.
Thank you.
Our next question is from Rachel Ramirez with CNN.
Hey, everyone. Thanks for doing this. Administrator Nelson mentioned the fires in Hawaii, and, the death toll is climbing each day, so this isn't going away anytime soon in the news cycle. So I was wondering if we could touch on that a bit more in the context of the global climate records that you all just laid out. And I'm curious if NOAA or NASA is gathering more data in terms of kind of establishing that climate change connection with the fires, and are there any scientific initiatives also being affected by the fires on the ground in Maui right now?
Gavin has his hands up. And also,
do you want to go to Sarah first?
Sure.
So this will be heavily studied. There will be a lot of research that comes out of both NOAA as well as our sister agency and Department of Commerce, NIST, who studies the wildfires and the effects of these things, in understanding specifically what caused this and the events that we've seen. Additionally, there was also drought present, which made it the dry conditions right in advance of it as well.
Thanks, Sarah. And Gavin?
Yeah, I think it's very important to note that when we have a disaster such as this, there are many antecedents. There are many little things that happened that give rise to these kinds of things. And so, there are local situations right on Maui that relate to abandoned sugar plantations, non-native grasses, the high growth of grass in the spring, the drying out that Sarah just mentioned there. But you've also got longer-term trends. You've got longer-term trends in rainfall. So storm tracks have been moving north with climate change. Hawaii has been getting, in general, less rainfall decade by decade. And so there are long-term effects that are contributing, but then there are going to be local and very specific precursors, including the ignition, that lead to any particular configuration. But what it is that you have to, I think, remember is that, there are lots of local things happening all around the world for all of these different things. But in general, climate change is a kind of threat multiplier for wildfires. And so there is an overall tendency that we will increasingly see towards greater and more intense wildfires that will be caused by climate change, whether this particular example, how much of a contribution it is, that is going to be something that we're going to be looking at very, very carefully in the future.
Thank you very much. Just a reminder to our folks on the line, you can press *1 to enter the queue. We have another question from Jim Siegel from NASATech.net.
Thank you. Have you drawn any conclusions about how much of the warming you've described is man-made, and has a man-made impact as opposed to the natural temperature cycles of the Earth? Thanks.
Yes, we have. We've been looking at this attributional problem for many decades now, and what we found is that the long-term trends that we've been seeing since the 19th century, particularly since the 1970s, they are all due to anthropogenic effects. The impacts of internal variability, the impacts of El Nino, the impacts of volcanoes, all of these things are very, very small compared to the anthropogenic component. And that anthropogenic component, the human part of this, is driven mostly by greenhouse gases, carbon dioxide the first, methane the second, chlorofluorocarbons the third, also ozone, and then changes in air pollution, deforestation all help. But all of those things are human created, and so without those human contributions to the drivers of climate change, we would not be seeing anything like the temperatures that we're seeing right now.
And Sarah?
Thank you.
Using both observations and being able to do statistical analysis on that allows us to also say what is the natural variability versus this response that we see that is so outside that envelope of the past historic variability. And as I said in my remarks, El Nino only increases the temperatures by roughly 0.1 degrees Celsius, and the warming is so far exceeding that. We also have models which are really critical for us to understand natural variability and the forced response that we see to human emissions into the atmosphere. And that, too, in recent decades, the temperatures that we are now experiencing, you can only get those temperatures if you include those greenhouse gas emissions into the atmosphere and the land use change that we have created on Earth. And so as a result, you only get the temperatures that we have right now, this enhanced warming, this value that is so far exceeding what our natural climate would be. So we are in a different climate state as a result right now.
Thank you. Kate?
Yeah, and just building on what both Sarah and Gavin said, as scientists, we're continually looking at what's happening on the Earth and what's causing those changes. And we use multiple lines of evidence, is what we refer to it in science. So different ways of observing the Earth. You add in models to complement observations. We have laboratory experiments where we can replicate the sorts of effects that we're seeing. And when we bring all that together, what we're seeing is that human activity and principally greenhouse gases are driving the changes we're seeing on the planet.
Thank you all so much. And we do not have any more questions. So you can play back this media event on nasa.gov/live and also learn more about our climate work at nasa.gov/climate. Thank you all so much.
That does it for this weekend's edition of the Carolina Weather Group. I'm James Brierton. Thanks to all our news subscribers streaming during severe weather, radar streams, which we call the Carolina Weather Net. We're so happy to have you here for our weekly show focusing on weather, science, technology, and more. We'll see you back next Wednesday with another edition of the show. For now, from Charlotte, I'm James Brierton. Be well. Talk soon.